Hey guys, what's going on? I got the last lesson of the week coming at you right here, so be ready for the celebration tomorrow. I will just basically post a screenshot of the celebration questions on Friday's page. You'll do them on your paper, and then you'll just send them right back to me in the turn-in spot, and should be good to go on that. So today we're going to talk about, remember yesterday I was talking about how there are really three cases to the ambiguous case. The one that we did yesterday was the one where the triangle does not exist. And the reason that it did not exist is because the way that the given information was given to us, it did not make a triangle. So there wasn't, the numbers didn't quite work out. Okay, so today we're going to roll through this. Again, make sure you remember that the triangles are not going to be drawn to scale by any stretch of the imagination. I'm going to make this one a little bigger, actually. They're not going to be drawn to scale by any stretch of the imagination, and we just got to roll with that. That's not a big deal to us, okay? So I've got A, B, and C. A is 55.3 according to this problem. Side A is 22.8 feet. And side B is 24.9 feet. So automatically I've identified my control. I've got 55.3 down here, 22.8 over there. I know that I'm going to be basing my calculations off of A. So when I go ahead and do, I'm going to scroll you down just a shade. When I go ahead and do my law of sines, I'll do sine A over A. The easiest thing it looks like to me is to solve for angle B first, because that's what we have. Also, just a quick side tangent here. Why could I not go ahead and solve for side C using the Pythagorean theorem? The reason for that is I don't have a right triangle, or at least I don't know at this point I have a right triangle. If the numbers work out and tell me one of these angles is right, then shoot, yeah, we'll do the Pythagorean theorem. But that's the reason why we can't. So I was afraid that a few of you might be thinking that, why we couldn't just go ahead and solve for that third side. It's because the Pythagorean theorem only works on a right triangle. So again, I'm using A as the control. I'm going to go ahead and solve for B, because that's the side length that I have that I'm associated with. 22, nope, that's not, that's A. I'm trying to put B here. And again, I'm going to fill in the information just like we did yesterday and the last few days. Sine of 55.3 over 22.8 is equal to sine of B over 24.9. Cross multiplying again, I think you're pretty good at this point. Cross multiplying again should give us, hang on, I wasn't trying to cheat up on example 2 there. Cross multiplying should give us 24.9 sine of 55.3 is equal to 22.8 sine of B. Looks like my variable ended up on the right this side, that's fine. And we're dividing. So that gives me sine of B is going to be whatever that large fraction is, so 24.9 sine of 55.3 all over 22.8. And as we talked about yesterday, we're going to do the sine inverse. So B is going to be equal to the sine inverse of typing in this whole thing, 24.9 sine 55.3 all over 22.8. So give me just a second, I'm going to type that in. So I've got sine inverse of 24.9 sine of 55.3, and that's all over 22.8. All right, so hopefully I didn't make any mistakes here. Normally Alec corrects me. So that tells me that B is 63.879. My A was given to me as one variable, one decimal place, so I'm going to go with 63.9 degrees. Okay, so this may put me off slightly when I do my calculations on the next part. At this point, it's hard to get around because I did have to round it to make my picture look right. So I'm going to go ahead and put 63.9 degrees up here as B. If you want to make your answers as a list, feel free. If you want to list out like angle B is 63.9 degrees, and then we're going to be finding angle C, and we're also going to be finding side C. So feel free to make your answers a list like that if you want. Okay, so here's the thing that we have to talk about before we move forward. taking inverses of signs like this is not as easy as it seems on the surface, okay? Because here's the reason. When I'm saying what is the sine inverse of all of that, what I'm trying to say is sine equals a certain thing, and I'm trying to find the angle that it exists. So me finding 63.9 right here was finding the angle that all of this was able to be the sine for. Okay, so I know that's a tough concept to grasp, but that's the way it works on these. Now, here's what I have to show you. Over here on the unit circle, just real quick, there are multiple places where the sines equal the same. Okay, so for instance, sine is 1/2 right here at pi over 6, but sine is also 1/2 over here at 5 pi over 6, because you remember these are ordered pairs, and cosine is the first number and sine is the second number in the ordered pair. Okay, so that's the way this kind of works, and you'll notice it works the same way around through here. Sine is square root of 3 over 2 at 2 pi over 3, and it's also square root of 3 over 2 at pi over 3. Okay, so sines match in quadrant 1 and quadrant 2. They're the same. Okay, so what we have to be able to figure out is what they match based on the situation that we just had. So what we just found out was our angle B is 63.9. Okay, 63.9 is probably going to be somewhere in this ballpark. Okay, that's where that number that we typed in, that giant number, was sine. Okay, so but that also means there's going to be something over here in this ballpark that is also the exact same sine. Okay, so I'm going to erase my green marks and I'm going to show it to you one more time. We found angle B to be 63.9, which is about in this general area right here where I've put my green mark on the right side. Okay, but according to this unit circle, the sines match across from the circle of each other. Okay, so over here in that same location is going to be the exact same sine. Okay, so what I'm trying to get at is sine inverse. Hang on, let me find a picture, or let me find my problem. Sine inverse is not only 63.9, but it's also something else. Okay, it's also something else. We're going to be able to figure that something else by figuring out what the alternate location is on the other side of the triangle, on the other side of the unit circle. So think about it like this. If I'm up 63.9 degrees, that matching green mark on the other side would be up 63.9 degrees going that way. Okay, that's a little bit hard to see, so let me erase it and draw it a little bit better. That green mark on the left is going to be up 63.9 degrees as well. So to be able to come up with the second angle that B could be, I simply need to do 180 minus that 63.9 degrees that we were up. The reason for that being 180 is this spot right here. Okay, so I know I'm 63.9 degrees up from 0. That means I'm also 63.9 degrees up from 180. Doing that, so 180 minus is going to give me 116.1. Okay, so this location right here is 116.1 degrees. That green mark right there. So the moral of the story, B is not only 63.9. I'm going to erase this right here. B is not only 63.9, but it is also 116.1. So that throws a big old wrench in our situation, because how am I going to put two different angles on the same triangle? That doesn't even make sense. How could I put two different angles in the same spot for B? Well, here's the way that we've got to do it. We have to draw ourselves another triangle. We've got A, B, and C. Put in the important information that they gave us, 55.3, 22.8, and 24.9. And instead of putting 63.9 in for B like we did on the last triangle, we'll put 116.1. Okay, so again, let me stress to you, these triangles are not drawn to scale, as you can obviously tell. They look identical, but they're not. They're obviously not drawn to scale. So that's the reason that I suggested maybe making the list of answers. So do B, do C, and then do little c. So I could put 116.1 as my angle on this triangle. Okay, hopefully that made sense. We're going to do another example here in a second. Hopefully that was able to make sense to you, that you can use that moving forward. If not, maybe example 2 will get it. But we're not done. So I still have to find angle C and side C in both of these pictures. So I'm going to go with the first triangle over here. I'm going to number them. That one's triangle 1. That one's triangle 2. So on triangle 1, I'm going to go ahead and find angle C by subtracting the other two angles from 180. So I got 180 minus 55.3. minus 63.9. So this angle is 60.8. So 60.8 degrees is angle C. And then I've just got to find side C. The cool thing about this is I've got a control and now I have an angle. So finding side C is just like what we did yesterday. So I'm going to use sine of A over A as my control. Now I'm using sine of C to find C. So putting in the information, sine of 55.3, not really sure why my pen is lagging here, but we'll just push through it, over 22.8 is equal to sine of 60.8 all over side C. Cross multiplying should get me C sine of 55.3 is equal to 22.8 sine of 60.8. Looks like I should have given myself some more room here, and we'll divide by sine of 55.3. So C equals, let me type it in, 22.8 times the sine of 60.8, and then divide all that by sine of 55.3. Okay, so 24.2. So side C is going to be 24.2 feet. All right. We got to do the same thing for triangle number 2 over here. So I can subtract 116 and 55 from 180. So 180 minus 116.1 minus 55.3. That gives me 8.6 degrees. It's pretty small, but it's not really a big deal. And I'll set up the exact same law of sines that I just did over here to find my second side C. Okay, so sine of 55.3 over 24.9 is equal to sine of 8.6 this time, because that's my new C, all over C. So after I cross multiply and solve for C, C should be equal to whatever 24.9 sine of 8.6 over sine of 55.3 is. I'm going to type that in real quick. All right, so 4.52. So I'm going to go 4.5. All right, so I forgot to put this stuff in my list. So 8.6 degrees, 4.5 feet, and this side C over here was also 24.2 feet. Okay, so I know that's a lot, but we still got just a little bit left in order to finish this problem. Okay, I've got to come in here and I've got to check to make sure this triangle exists, just like we have been doing the last few days. Remember I told you how this was going to be important? Here's why it's important. Okay, so I've got the smallest angle is 55.3. That's across from 22.8. That is the smallest side, so it checks out. The middle angle is going to be 60.8, and that is across from the middle angle 24.2. It's close, but it works out. And then 24.9 is across from 63.9. So triangle 1 works out. Triangle 2. Let's make sure it works out. Smallest angle is going to be 8.6. That is across from 4.5. That is definitely the smallest angle. The middle angle is going to be 55.3. That's across from 22.9. that checks out. I think it's actually 22.8. That checks out. And then 116 is across from 24.9, so we are good to go on that. So you may be asking yourself, how would I answer this question? What even is the answer? We've been like in 30 different directions. Well, the answer to this question is these three pieces of information and these three pieces of information. Okay, so we need to understand that there are two triangles, and feel free to just leave your answers as the triangle like this with all the information written on it. Okay, the blue, your options for answers are either the blue circles or the green rectangles. So feel free to do that either way. Okay, now I know this is getting to be a little bit of a long video, but we're going to roll through example 2 here. We should be able to do example 2 a little bit faster. So I'm going to draw a triangle. Let me make the line just a little bit straighter. So I've got A, B, and C. A is 43.5 degrees. Side A is 10.7. And side C is 7.2. Okay, you're probably guessing that we're going to end up with another triangle. So I'm going to go ahead and draw, this is triangle 1. I'm going to go ahead and put triangle 2 on here. And understand that it has this same information to start. Okay, this stuff cannot change because this is given to us as part of the problem. Okay, so I'm going to set up, I'm going to be working here. The steps are going to be the same just to find angle C. So I'm still going to do sine of, A is my control, so I'll put a red box around it. I'll do sine of 43.5 over 10.7 is equal to sine of C over 7.2. After I cross multiply and isolate sine of C, I should get sine of C equals 7.2 sine of 43.5 all over 10.7. If you need to actually write out the cross multiplying and then divide, feel free to do it on your paper. You can pause me at any time. So then after I take the sine inverse, C should give me whatever the sine inverse of all of that is, and I'm going to type that in. So sine inverse of 7.2 sine of 43.5 all over 10.7. So that gave me 27.59. So I'm going to go with 27 point. I should actually go with 27.6 to round that up and make it right. Okay. Now I'm going to take you back over to the unit circle for just a second. 27.6 degrees. Remember that. All right. I'm going to have to erase some stuff over here on the unit circle. That's okay if you need to see it. Rewind the video and watch it earlier. Okay. 27.6 degrees. Let me check to make sure that's correct. Yep, 27.6 degrees is gonna be somewhere in this ballpark. Okay, so I've got to find the match over here on the other side. So I know up from 0, it is 27.6 degrees. So up from 180 on this side should be 27.6 degrees. So in order to find that value, in order to find that value, I'm going to do 180, and I'm going to subtract 27.6 degrees, which gives me 152.4. So this spot right here is 152.4 degrees. So that's my alternative angle C. Okay, so it could be 27.6, but it could also be 152.4. So when I put that information, let me get you zoomed back in here to where we can see stuff. So when I put that information up here on my picture, yes, picture 1, angle C is going to be 27.6 degrees. But over here on picture 2, it's going to be 152.4 degrees. Okay. Finishing out triangle 1, I'm going to find angle B by doing 180 by subtracting the other two things. So 43.5 and 27.6. That gives me 108.9. And I'm going to use the law of sines to figure out what the last one would be. So using my control again, here's what I'm going to do. I'm just going to visualize that this is no longer here, and I'm going to set it up for B. So that would be sine of 108.9 over B. All right, so after I cross multiply and stuff, I'll really be finding whatever 10.7 times the sine of 108.9, and then dividing that by the sine of 43.5. Again, if you need to write all that out, feel free, just pause me and then pick me back up after you're done. So 14.7 inches on that one. And then finishing out triangle 2 over here, I'm going to figure out what angle B is. So 180 minus 43.5 minus 152.4. Oh, that gives me negative 15.9. Negative 15.9 degrees. Is that a thing? Is that even possible? That's what we have to ask ourselves here. Okay, so let's come back to triangle 2 in just a second. Let's make sure we are good on triangle 1. So the smallest angle is 27.6. That's across from 7.2. That's the smallest side. We're good there. Middle angle is 43.5. That's across from 10.7. That's okay. And biggest is biggest on B. Okay, so triangle 1 works out. But what we have to ask ourselves is triangle 2 going to work out? Okay, so this way, we've got 152 in one of our angles, 43.5 in another, and that doesn't even leave us any left for angle B. Okay, we need 180, and we're subtracting both of those, and we've got too much. Okay, so we have too many angles. So the verdict of the story here is that triangle 2, there's no way for it to exist. Okay, so we'll just say triangle 2 does not work at all. Okay, so in this case, the answer to your question is only going to be triangle 1. All right, so these are the other two cases of the ambiguous case. Now, let me caution you. Sometimes you can even construct all of triangle 2, but what happens is the smallest angle might be across from the biggest side, and then that wouldn't work out. So that last step where you check to make sure the angles are across from the right sides is essential. It's very, very important because sometimes triangle 2 may exist, and it will not work out like that. So definitely go in and check that to be your last step. Okay, so the verdict of today is these are the other two cases of the ambiguous case. Okay, so remember the first case of it was there is no triangle that exists because it gave you an undefined answer. The second case would be like example 1 when you have two full triangles that are your answers. Okay, and then the third case of it would be like the third triangle, the example 2 down here, where you almost had two triangles, but the second one didn't work out. So you just output one triangle as an answer. Okay, so hopefully this makes sense to you. I'm tried to be as clear as I can. Feel free to ask me questions. Let me know if you didn't understand this, and I can do another video on Monday of next week. So just let me know early so that I can plan for that. We should be okay on it though, so just let me know. Make sure you don't have any problems. Okay, so here's what I need you to do today. On page 311, I need you to do 21 through, hang on just one second, 21 through 26. But yesterday you did 23 and 24 already, so just omit those. Okay, so you did 23 and 24 already, so there's no reason to do those. So do basically 21, 22, and then 24, 25, and 26. I should be able to figure that out. If not, send me a message. It's pretty self-explanatory. Okay, so hopefully you guys did okay with this. If not, let me know. And celebration coming at you tomorrow. Other than that, have a good weekend, and I will talk to you on Monday.